Hi, everybody. Here's a video to help you with the next section on equations of circles. So we're going to go ahead and derive the formula, and then I'll show you how you can use it. Good news for deriving the formula. It's definitely a formula that you're going to find familiar. It's just going to look a little different in the context of, the coordinates that we're using for the circle. So here we go. We have a generic circle here centered at the point HK. Sorry, it's a little fuzzy. I tried to get a little clearer, but I can't get it to work much better. So hopefully on your paper, you can see clearly that this is HK. And then just a random point on the circle, XY. Okay, so here's my circle. And we're going to try to find the equation for the circle that represents all the points on here. All right, so the first thing we're told to do is create a right triangle by drawing a horizontal line through HK and a vertical line through XY. So basically, we're trying to draw this right triangle here. And there you go. There's your right triangle. Horizontal through the center, vertical through the random point XY, and we're guaranteed a right triangle there. Now, what expressions can we use to represent the lengths of the sides of the right triangle we created? So the hypotenuse is here, the vertical leg is here, and of course the horizontal leg is here. Well, hopefully we can just use r for the hypotenuse because that's the radius of the circle. So that's probably going to be the easiest way to represent that. The vertical leg, so here's xy. What are the coordinates of this point? Well, it has the same x value as this one does, and the y value is the same as the y value for here. That's where the k is. So the coordinates of that point are actually x, comma, k. Now, what's the distance between these 2 points? Well, again, it's vertical, so all we really have to do is deal with the difference in the y values. So you can almost imagine there's a number here. Let's say this was 5 and this was 2, and I asked you how far this was. Well, most of you would easily just say 3, because 5 minus 2 is 3, right? You went 3 more units. Well, we don't have numbers for this, so we're just going to use the generic y and the generic k. So whatever that difference is, y minus k, is the length of our vertical segment. Our horizontal leg is basically the same idea, but we're going this way. So instead of the the y value changing, because the y values are k for this, the x values changed. So you'd have x and h, and the difference there would be x minus h. And if you're worried about, well, which way does it go? What if you were on this side? Do you still do it that way, or do you have to do h minus x instead, or something like that? That's a great question. Normally for distance, I would use absolute value just to make sure that the distance ended up positive. But when you see what we do with this equation in a minute, you're going to see it's not going to actually matter. It'll work both ways. So for the generic purposes, this is typically the way we'll write it. And now, since it's a right triangle, we can use the Pythagorean theorem to write a relationship for all 3 of these sides. A squared plus b squared equals c squared. So here we go. X minus h squared plus y minus k squared equals r squared. And just like that, oh, is that cut off there? Just like that, we have the equation of a circle. So as long as you know what h and k are, and you know what the radius is, we should be able to graph the circle. Or maybe we know some of the points on the circle and we can backfill the rest of it. But the equation of a circle comes directly from understanding the Pythagorean theorem, just doing it kind of generically. That's why I said it would look familiar. And again, if you were worried about the distances staying positive, by squaring the value, no matter what, we're going to get a positive number, unless it's 0, obviously. But that's not very exciting for a circle. But it could happen. So let's see. We've got a squared plus b squared equals c squared, and there's the equation of the circle. We call this the standard form for the equation of a circle. So when we get to the next little part here, it's asking us for that information. The standard equation of a circle with center hk. Let me try to focus this one more time. Yeah, I think that's as good as I'm going to get it. So the center is hk and the radius r. So here we go. It's going to be x minus h squared plus y minus k squared equals r squared. And again, hk is the center, and r is the radius. So here's an example. They're going to ask us for the equation of the circle. The center is 3, -1. So here's your h and k, and the radius is 2. So there's your r. So let's go ahead and write the equation of the circle. So this is x minus 3 squared plus y. Now I'm subtracting -1, so that would make this plus 1 squared equals r squared, which is 4. The center is 3, -1. 1, 2, 3, -1. There's my center. My radius is 2. So if I'm going to try to plot this, I'm going to draw a point in every direction possible, just counting off 2's, right? There's the radius of 2, and then I just do the best I can. So curvy, 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 all the way to curvy, all the way back. And there's my circle centered at 3, -1 with a radius of 2. Okay? All right. Now, let's do a couple more examples. Make sure we're good. Now, here's a special case when the center is 0, 0. That's basically telling you that h and k are both 0. So when I do, x minus h squared, that really just becomes x squared. And then y minus 0 squared is really just y squared. Let me, I think this is trying to autofocus and it's kind of messing it up. Okay. Equals the square root of 2 squared. But of course, the square root of 2 squared is just 2. So the center is 0, 0. So x minus h squared was really just x squared. And y minus k squared is really just y squared. And then the r squared just becomes 2. So there's your equation. Now, this will always happen when you're centered at 0, 0. You'll end up with just x squared plus y squared. If one of them was 0 and not the other, well, then you'd have maybe an x squared, but this would still be a y minus something, etc. But this is kind of a special case here. And you can see the same kind of thing happening for b. If you want, you could pause the video, try to get this one on your own, and then unpause when you're ready. Since we are centered at 0, 0, I'm just going to jump right into the x squared plus y squared. And then I just got to do a little bit of interpretation here. The diameter is 18, which means the radius, of course, is 9. 9 squared is 81. So that would be the equation of that circle. All right, this one looks like they're giving me the endpoints of the diameter. So I'm going from 4, 6 to -2, 6. So really, it's just a horizontal segment if you think about it. And the distance between these two endpoints, let's call this A and B just to be clear. The distance from A to B is simply the distance from 4 to -2, which is 6. So that's the diameter. That means the radius is 3. Now, that's not so bad, except for the fact that I still don't know what the center is. I just know this is the diameter. Well, where would the center be in relationship to the diameter? It'd have to be in the middle. How do you find the middle? You find the midpoint. So the midpoint is going to get us the center of this circle. So the midpoint is simply just going to be the average of the x's and the average of the y's. So I'm going to have 4 plus -2, so 4 plus -2 over 2, comma 6 plus 6 over 2. Obviously, that's going to just end up being 6 for that part. And so this becomes, what's that, 1, 6. So there's our center. That means this is h and this is k, because that's our center point. Now we have hk, we have the radius. We can literally just write the equation of the circle. Y minus 6 equals 9. And there you go. So one more time, if they don't give you the information as directly as you'd like it, sometimes they, want to make you do the work for it. Well, if we know the endpoints of the diameter, that instantly could tell us what the radius is, and that also can tell us what the midpoint is. Now, you might be asking, and hopefully you are asking this, what if this wasn't, what if these weren't both 6's? How would we find the radius that way? I can't just do the difference between 4 and -2. Well, since we are looking for distance, we would use the distance formula. So no matter what the 2 points are, if they're the endpoints of the diameter, right? If you know, let's say they gave us the diameter going this way. If we know what the coordinates are of those endpoints, let's just say that was for this problem, we could find the distance and then just divide by 2 to get the radius. Then we would do the midpoint to find the center if they gave it to us that way. All right, so this one actually, because they graphed it, it's kind of easier. We know the center is -3, 1, so there's your h and your k. And we can get the radius pretty quickly just by checking it out in the grid. 1, 2, 3. So the radius looks like it is just 3. So x minus -3 is the same as x plus 3, plus y minus 1 squared equals the radius squared, which is 9. Oops, that got cut off. There you go. Just a coincidence that both of those are 9, obviously. All right, that should basically get you through all the main concepts when it comes to the equations of the circles. But I'm going to show you one more advanced technique where sometimes things can get a little messy. So check this out. Sometimes we have the general form given to us, or we have information that leads us to the general form. And basically, if you take your equation of the circle, let's just look at this one here. if you were to FOIL this out, right, if you were to distribute everything and rewrite this whole equation by combining as many like terms as you could, you might end up with the form that looks like this. But what if we have to go backwards? What if we have this form, but we need to write it in this form? And it's helpful to have it in this form because this gives away the center and it gives away the radius. It's pretty hard to look at this and know where the center and the radius is. Kind of like when you do y equals mx plus b, but they write it in the other form and you're trying to figure out what the slope is. It's much easier to find the slope when you have y equals mx plus b. Same thing with the y-intercept. So there is a way to do this algebraically, and it does involve a little bit of manipulation. So hopefully this is kind of familiar as far as the steps that I'm going to use. The first step is to just group everything. So I want all my x terms together, I want my y terms together, and I want to get all my constants to the other side of the equation. So here we go. We have x squared minus 2x plus y squared minus 4y equals positive 4. So now I have all my x's together, my y's together, and my constant all by itself. Now I'm going to do a technique called completing the square. Now maybe you haven't heard this term before. It's basically just forcing a good factor to happen, factoring. So we're going to force this to factor nicely, but normally we need another term here in order for that to work. Same thing here. So what I'm going to do, I'm going to divide this by 2, and then I'm going to square that number and add it to this grouping. So negative 2 divided by 2 is negative 1, squared is positive 1. So I'm going to add 1 to this grouping, and I'll even just use parentheses to emphasize what I'm doing. Now, if I do it to this side, I have to do it to the other side as well. I added 1 to both sides. I'm going to rinse and repeat for the y squared term. Y squared minus 4y, divide negative 4 by 2, and then square it. Just happens to be another 4. And if I add 4 to the left-hand side, I got to add 4 to the right-hand side. Now, this factors beautifully. It's a perfect square factor. Oops, sorry, that should have been a 1. X minus 1 squared. So if you factor this, you're going to get x minus 1, and x minus 1 is both of your factors. So that's x minus 1 squared. Same thing here. That's the whole point of doing it this way. Y minus 2 squared equals 9. Now we can figure out what the center is and what the radius is. The center is going to be 1, 2. That's the center. And my radius is 3. And now we can graph the circle pretty easily with that technique. Okay, so one more time, group everything. Do this little trick here for finding the extra term. Divide the b term, right, the middle term by 2, and then square that number. Whatever you do here, do here. Same thing, divide by 2, square it. Whatever you do here, and then simplify. And here's a couple to try. So if we want, you could pause it and see if you can get them without my help, but I'm going to show the solution right now and do it for you as well. So here I go. X squared. There's no y term for this one. So I'm just going to, or there's no x term, I mean. Y squared minus 6y equals negative 5 if I bring that 9 over. So this one's already set. So I'm just going to leave the x squared alone for now. Y squared minus 6y, negative 6 divided by 2 is negative 3. Squared is 9 equals negative 5 plus 9. And I just realized this was already a perfect square factor. I probably didn't even need to do this. Watch what's about to happen. X squared plus y minus 3 squared equals 4. So I got right back to the 4 that I started with. I just kind of blindly went into this. I thought I was going to do the exact same thing I did before. I forgot that this one was already set up to be a perfect square factor. So I'm kind of glad that happened because that may happen to you too. Not that I was planning it, but you can see it still worked. I completed the square, but I ended up kind of right back where I started. So if you didn't recognize that this was going to factor nicely, that's okay. This trick will always work. So here's my circle, centered at 0, 3 with a radius of 2, right? I have no h term here. So x for my h term is 0, I mean. My y term is just 3, and so my center is 0, 3, and my radius is 2. All right, let's see if this one makes us do a little bit of work here. Yeah, it looks like we have to do this one all the way out. So here we go. X squared minus 8x plus y squared plus 2y equals 21. This becomes x squared minus 8x. So that's going to be 16 plus This is going to be 2y plus 1. So now I got to add 16. I also got to add 1 to both sides. So I'm adding 17. So that's 38. So here we go. X minus 4 squared plus y plus 1 squared equals 38. So it looks like my center is at 4, negative 1. And my radius is the square root of 38, whatever that happens to be. Okay, so that should help you get through all the different types of circle equation problems that you're going to have to deal with. If you need to revisit this video for any reason, by all means, just go back and rewatch. If you have any questions about it, let me know. And I apologize again, that's a little on the fuzzy side. I did the best I could. Okay, have a good one, everybody. And I hope to see you guys on Monday.